आलाय का? स्टाफ रूमला येतं, मी स्टाफ रूमला चालू केले. लेक्चर होतं तुम्हाला आज? कुठलं? हा हा हा. ना आता मी त्याच्यावर केली आहे, माझं मगाशी होतं, पण ते मुलांना आधीच्या लेक्चरचा प्रॉब्लेम झाल्यामुळं पोरं लगेच हे झाले नाही. मी मला 11 वाजता घेऊया. चालू आहे आता 26. हॅलो, एम आय ऑडिबल? दोज हू आर जॉईन?
Yes, sir. Yes, sir.
So just 26. So we will wait for some time that whether all should join. Almost about 30 when the number will go, we will start our regular lecture. Be remember that from yesterday, college has changed the program. Instead of Zoom, college has started the lecture on Google Meet, and everyone know that government also insist us to take the lecture on Google Meet. So in that regard, college has started instead of programming, scheduling the lecture by a staff member, they have given directly the timetable, hyperlink is there, and directly we can start with Google Meet. So now in the initial stage, you have observed some difficulties, no doubt, but I think when we can properly do, everyone should join. So somewhat problem you have faced in the morning, and but by using same link, I have same email. I have start this meeting, and yeah, almost 27 students have been participated. Just we are waiting for 5 minutes more, and we can start our lecture. Uh, so we have to just wait for 5 minutes, and just we can check whether other will join. And from tomorrow onwards, definitely we will going through this, because this is convenient for all. And we will see at the initial stage we will face some problem, but later on we can smoothly conduct the lecture. And if there is any kind of difficulty, you can share your views. And also be remember, you should feel the feedback, whether after this uh, completing lecture, if there is any option in Google Meet to give feedback. So if there is available such option, then you should give there also. And as well as we will provide weekly feedback form to you also. So just we can wait for 3 minutes more, not more than that. And just we'll check 28 students have been joined. And you also observed, I think, Ankita, you have seen that.
Yes, sir. Yes,
Ha,
sir.
so you will take the regular snap of total participant. Now it moved to 29.
Yeah.
Just we can wait for 5 minutes because this is the first time. So I will take 5 minutes more. So everyone should join. Once they know how the process is going on, no doubt it is little bit new for you as well as us also, because I am first time I am using this Google Meet as a host. Means I have joined 2 3 functions on this Google Meet, but not as a host. I have not operated this, so I am also operating first time. So just check. Almost 10th in 32. तू पण झालं जॉईन खाली आलास लिंकला नाही जॉईन व्हायचं ते पास क्लासरूम मधनं लिंकला तुला दिसेल तिथे लेक्चर सुरू झालेलं आहे बरं थांब की मी काय म्हणतोय शेअरच जरा बघूया uh, I think 32 are joined. In the morning lecture, I think 38 students were participated, right? So where are
Yes,
rest
sir.
of the students? 33. Uh, and I think in admission process, almost everyone have taken admission except one. So please confirm him that whether he will take the admission or he has some problem to contact Mulani, I think. So if any friend of Mulani, he or she will contact him and just ask what he has any problem regarding admission process. So definitely department will help him. And now onwards, be remember everyone should join in time. And yeah, this record is not only restricted to our college, but this information is also go to our samstha, because they have asked the total number of students who have attended the lecture. So be remember and be serious about attending the lecture. Anyhow, you have to disconnect due to the internet problem. Everyone should immediately try to join, because this number is going to Raj Shikshan Samstha. So yesterday only the circular has been arrived and we have sent information. Up till now, no doubt our department having the maximum lectures of 4 stream. So definitely that is creditable to us. But as far as the attendance is concerned, we are little bit poor as compared to other departments. So now from onwards, you should focus on this attend depart. So I think 35 students have joined. Those who are joined later on, I will join in them, and Ankita will take the snap of this attendance.
Yes, sir.
Okay. So just I will start our PPT नाही open येते. काही ते फुल स्क्रीन येत नाही. फुल स्क्रीन येते ना. अरे हा विंडो आहे ना, स्क्रीन नाही. ठीक आहे. Okay, are you seeing the PPT?
Yes, sir.
Okay, so we'll start the our lecture. In the previous lecture, we have started the disconnection of ketone, and in the last lecture, we have focused on enamines, how the enamines can give a particular substitution at alpha position of the ketone. And in the last slide, I have focused on another approach, that is the reverse of polarity, in which when we have give the charge on the synthons, either positive or negative, in that we have observed acetyl carbocation is one of the synthon and alkyl anion is other synthon, that is our regular disconnection. But when we can take opposite charge, that is alkyl carbocation and acyl carbanion, then it is the reverse of charge, and uh, in that case we have to use umpolong, right? So we know that umpolong, it is the inverse or reverse of polarity. In organic chemistry, umpolong is the chemical modification of functional group with the aim of reverse of polarity, and that allows the secondary reaction of this functional group that otherwise it is highly impossible, it is not takes place. And this concept was introduced by Sewage and Ecori, and this polarity that can analyze the chemist when the umpulang, actually we can use such kind of tactic for the synthesis of particular target molecule, otherwise such kind of synthesis is regularly not takes place, and that's why umpulang is useful. Generally short note is always asked on umpulang. Be remember, at the later part of this topic, definitely we will again go through the reverse of polarity. The question may directly ask, write short note on reverse of polarity, or question is asked, write short note on umpolong, and what is the use of umpolong in retrosynthesis. So there are so many options are there to ask the question, but you must focus on this. Just we can uh, going through one example over here, and later on in the reverse of polarity part we will see in detail. So here we know that the normal reaction is that nucleophile is attack on carbonyl carbon because it is electron deficient. And when we can see the umpolong, the reverse of polarity is there. That is nothing but the acyl carbanion is generated, and that will attack on the electrophile. So this polarity can be inverse or can be reversed by using 1,3-dithiene. So this is the structure of 1,3-dithiene, in which there are two sulfur atoms are there in the cyclohexane ring, which is electron withdrawing, and this methylene group, which is flanked by these two electron withdrawing group, are acidic in protons. So these acidic protons are easily picks up by the base to form carbanion, and that attack on aldehyde. So when you can see the synthesis of such kind of umpolong, any aldehyde. So here the synthon corresponds to synthetic equivalent is acetaldehyde. So we can take acetaldehyde and 1,3-diethiol react with acetaldehyde in presence of Lewis acid. It can form such kind of dithione. And this substituted dithione, there are two acidic protons are there. Out of that, this carbanion is generated, which can attack this Lewis acid. So here it can form such kind of thing. So in presence of base that is N-butyl lithium, that picks up this acidic proton. And this acidic proton react with alkyl halide to form corresponding dithione. And after reaction with mercury chloride in presence of water, methanol system, or by using astronitrile system, we have obtained corresponding target molecule. So in this way, uh, from aldehyde to ketone, normally this kind of synthesis is not takes place, but here we can use such kind of system. Now we can start with another, that is the disconnection of aryl ketones. So in the ketones, we have up till now observed the aliphatic ketones. Now we'll move towards the aryl ketones. So in the aryl ketones, we have observed there are two kind of disconnection, either this A or B. So when we can prefer A, it can give the carbonyl group. When we can disconnect, it can form acyl chloride. And it is a simple electrophilic substitution reaction, that is Friedel-Crafts acylation. Now in the part B, with respect to another aromatic ring, here also same kind of synthons are there, and we can get corresponding, this carbocation get positive charge and this benzene ring get negative charge. Here also this anisole get negative charge and this acyl carbocation get positive charge. Now question is arises, there are two kind of synthetic equivalents are there. No doubt both are having benzoyl chloride. Now out of these two, which is the correct path? So if you observe in B, nitro group meta directing, and which can deactivate the Friedel-Crafts acylation reaction. And A, both group are activating and ortho directing, and ortho that is methoxy group, which donate the lone pair of electrons, so it can more electron donating as compared to methyl, and that's why in that case A is the best method. Okay, so did you understand this part? Now
Sir.
when we can see another kind of ketone in which there is beta position, there is another function group like hydroxyl, and we have observed in the alcohol part, when the two phenyl groups are there along with alcohol, we can prepare corresponding Grignard reagent and ester. Now here also we can move like this. Now question is arises, when there is ethyl acetate is there, it is very difficult to attack the Grignard reagent because there are two competitive electrophiles are there. One is carbonyl carbon and other is ester carbon, and that's why there is both ketone as well as ester carbonyl group is there, and it is get a number of product, and that's why instead of getting the our target molecule, we will get the different product. And now, so to protect this, because when we have to obtain this ester or we have to attack this Grignard reagent on ester, we must protect this carbonyl group, and this can be carried out by using cyclic ketal formation. So here when 1,2-diol react with ethyl acetate in presence of acidic medium, there is protection of carbonyl carbon instead of ester, and then it react with Grignard reagent, two equivalent of Grignard reagent, we have obtained corresponding tertiary alcohol after hydrolysis. And then as in a acidic medium this workup is there, this acetal group is also removed. So deprotection is also takes place in acidic medium. Otherwise we have to deprotect separately. But as the medium is acidic, the deprotection is also takes place, and the final product formation also observed. Now, so any functional group can act as a protecting group, provide that can be easily added and removed after completion of a reaction. But in some cases, instead of protecting one part, it is better to activate the other part. So that is also one of the way. So no doubt in organic synthesis, generally protection and deprotection protections are carried out mostly, but on the other way also, instead of protecting, one can activate one part than other. So the reaction is carried out from that site. Now, if we take acetone in pints of base, when it react with benzyl bromide, we have obtained corresponding ketone. Now, no doubt when we can carry out such kind of reaction, the yield is very, very poor because of enolization. And the product is reactive to as a starting material back. And that's why this further reaction is occur. That is nothing but we know that in alkylation, polyalkylation is also takes place. So on either side, this benzyl bromide can attach and we can get a number of products. So there are two different products are all obtained, and that's why we cannot get the target molecule. And for this purpose, we have to activate the one part. So generally in ketone, when such kind of compound is there, be remember we have to activate this ketone by adding this COAT group additionally. Now this we have added this COAT group, and we know that when we can get out ethyl acetate now, so instead of acetone, we have taken as a starting material is ethyl acetate, and in presence of base, when we can carry out a reaction with benzyl bromide, we know that the methylene group, which is flanked by ketone and ester, they can be more acidic, and the protons are more labile. So base can pick up the acidic proton that react with benzyl bromide, and after workup, we can get alkylation at methylene carbon. So here now the another site is not undergo alkylation because this is more active instead of the terminal methyl group. Okay, and that's why the substitution is takes place at methylene carbon, and then we can carry out workup and remove hydrolysis followed by decarboxylation. We can get the product. So if we see once we can get the starting material, we can carry out the reaction by our regular process. This is acidic, so it is a formation of enolate in presence of base. Then it attack by benzyl bromide. We can get corresponding CH2pH. So first we can carry out either acid or base hydrolysis. We know that ester is converted to corresponding acid. Then it undergo decarboxylation. We have obtained corresponding enolate, and in enolate tautomerism we obtain corresponding ketone. So in this way the product is formed. Now when we can take the alpha bromoketone and when it carried out the bromination, we know that when such kind of target molecule is there, there is side chain containing bromine and benzene ring containing bromine. So first of all we can disconnect at this side chain and CBr bond breaking is takes place, and we have obtained acetophenone. So parabromoacetophenone is the intermediate. Then we have to disconnect this benzene ring with this carbonyl carbon, and we know that is a simple Federer-Kraft acylation reaction is there that we already know, and that's why when we can take the bromobenzene and acetyl chloride, we have obtained corresponding acetophenone, and then it undergo bromination. Again we have to use the mild condition for bromination. We can get the side chain of the ketone undergo halogenation. So that already we have carried out such kind of reaction at practical. So it is a very simple synthesis. That is nothing but the bromobenzene react with acetyl chloride in presence of AlCl3 anhydrous is there. We can get acetophenone. This acetophenone in presence of bromine and acetic acid, we get corresponding halogenation, or we can call it as bromination to the side chain instead of benzene ring. Be remember, when we can use bromine water directly, then it is very difficult. When we can use bromine and acetic acid, then and then only we can get the substitution at side chain instead of this aromatic ring. Now, these are some reactions that gives aldehyde or ketone, which are obtained from corresponding uh, alkyl halide, alcohol, acetylene, alkenes, acid chloride, acid, ester, cyanide. When such kind of starting materials are there that are converted to aldehyde. So these are some common reaction that you already learned. The oxidation, different reagents also that part is going on. And by using different reagents, we can carry out such kind of reaction to prepare the aldehyde. So once you know such kind of reaction, you have to imply in the retrosynthesis. Similarly, when we can see the ketone, then the ketone can be obtained from corresponding acyl chloride, acid, alkynes also, right? So when you can take HgSO4, we can get a reduction, and OH is there in presence of acidic medium. Alkene is converted to alkyne, also alkyne is converted to alkene, and then when we can add water, we have obtained corresponding ketone. So such kind of reactions you already know, and that's why we can carry out such kind of ketone is obtained from secondary alcohol, acyl chloride, and we can get such kind of astrophenone is also obtained by Fiedel-Crafts acylation. So these are some common reaction of aldehyde as well as ketone, right? Now, when we can see the carboxylic acid, so anyone can say how the carboxylic acid is obtained? How you can obtain the carboxylic acid? Anyone?
Oxidation of aldehyde.
Okay, oxidation of aldehyde. Second thing,
Reduction of alcohol.
reduction of alcohol or oxidation of alcohol. Hmm? So oxidation of alcohol be aldehyde first and then as corresponding acid. Any other reaction before we can start? Because you know that in the first lecture I have told you that when we can carry out retrosynthesis, you must know the each and every reaction of formation of functional group, that particular, as well as their reaction. Once you know that one, it is a very basic thing. Since 11th standard, you have already learned aldehyde, ketone, acid, ester, alcohols, amines, amides. These are the basic functional group. Even though they can be at 1 2 position or 1 3 position, that doesn't matter. But in that case, if you know such kind of reaction and some known reaction, then retrosynthesis is very easy, and this is very important part. Okay. So generally carboxylic acid is obtained from alcohol by oxidation, and we know that it is well known that when we can disconnect this decarboxylation, CO2 is there and this R minus is there. So R minus is always preferred to the corresponding RBr that gives Grignard reagent. So synthetic equivalent corresponds to R minus is RBr, that is synthetic equivalent alkyl bromide, and when we can add magnesium, we can get the corresponding carbanion. And when we know that this is well-known reaction, Grignard reagent react with dry ice, we have obtained corresponding acid. And in that case, we have observed the reactivity. Acyl chloride is more reactive as compared to anhydride, ester, as well as amide. So acid derivatives can be formed from the acid. So COH is converted to corresponding acid chloride, ester, amide. Okay. Now, we know that the acid is obtained from Grignard reagent and it undergo acylation. That acid is converted to acid chloride. This acid chloride is converted to acetic anhydride. And here, this acid chloride is also converted to amide. And when we can carry out the hydrolysis of anhydride, we can obtain the acid also. Similarly, anhydride is also undergo hydrolysis to obtain corresponding ester also. And ester, when undergo acid as well as base hydrolysis, we obtain corresponding acid also. So in this way, there are the path through which we have interconnect all organic compound that having a different functional group which connect with the acid. Now we know that when we can take simple aliphatic acid, always we can break the carbon which is attached to the COH function group. So when we can disconnect this position, we can get corresponding R plus and COOH minus. So here, this is the one way to break the carbon-carbon disconnection, or second way, that is nothing but we have to use function group interconversion. So here, when we can carry out the function group interconversion, we know that the acid is obtained from cyanide, right? Now the question is arises, how we can obtain this alkyl nitrile or alkyl cyanide? So again, we can disconnect this carbon-carbon bond. We have obtained alkyl bromide and corresponding cyanide. So that is nothing but from alkyl halide also we have obtained corresponding acid. So that is carried out by using functional group interconversion. And on the other side, when we can disconnect the bond between COH group and alkyl side chain, we have obtained R minus and CO2 plus. So here, this R minus is corresponds to RBr, that is alkyl bromide. But when we can get such kind of negative charge, this is only takes place by using the Grignard reagent. So alkyl halide is the starting material for both the way, either by disconnecting or by using functional group interconversion. So both the way we can prepare the acid. Now, we know that when we can carry out alkyl halide, we react with magnesium metal in presence of dry ether, followed by reaction of Grignard reagent with dry ice, we have obtained corresponding acid after acid workup. So after acidic workup, we have obtained corresponding acid. So this is the one of the route to synthesize the acid. Similarly, by using the here we can take example like allyl bromide. When this allyl bromide react with cuprocyanide, we know that bromine is replaced by cyanide group. So and in presence of acid, it easily undergo hydrolysis to obtain allylic acid. So in this way, by both functional group interconversion as well as carbon-carbon disconnection approach, we can obtain the simple aliphatic acid. So that is very routinely carried out this kind of synthesis in industry. Okay. Now, suppose we can disconnect the bond instead of 1 2. This is carbon number 1, that is functional group COH. This is carbon number 2. So at this initial stage, we have observed this 1 2 disconnection. Now when we can disconnect the bond between 2 and 3, what will happen? So here we can get Br and here we can get negative charge. Because this carbonyl carbon get positive, this is the acceptor D0, sorry, A0 acceptor, and D1 is the donor. So here D1 synthon is CH2 minus COH, and we can take corresponding synthetic equivalent for such kind of synthon. Be remember, this is very, very useful synthon. Here we can get diethyl malonate. So when we can carry out synthesis of this in presence of base diethyl malonate, here we can get the carbanion, it react with alkyl halide, we can get side chain. After this, when we can carry out hydrolysis, we can obtain diester is converted to diacid, and when we can heat it undergo decarboxylation and we can get corresponding acid. So in this way, by both the disconnection of carbon-carbon at 1 2, 1 3, as well as by using functional group interconversion, a simple acids can be disconnected. Now, here also we can use Umpolongo approach, and that's why at the very first slide, I have focused on reverse of polarity, because reverse of polarity is nothing but just we have to change the charge on the synthons, right? So once we can change the charge on synthon, we have obtained the reverse of polarity. So different kind of examples are there. It is not necessary for aldehyde or ketone. There are so many examples, and that's why the short note, when it asks in exam, you should give the variety of example, not only for particular only one example. Be remember. So here, when we can disconnect such kind of aliphatic acids, no doubt it is mostly applicable for aliphatic acid instead of aromatic. So directly aromatic acids are obtained from the hydrolysis of cyanide and corresponding bromide. So that is very simple example, right? Now when we can disconnect this bond, there are two kind of synthons are there, in which in the first case carbonyl carbon get positive charge, that is our normal reaction, and corresponding side chain get negative charge. And we know that the carbonyl carbon get positive charge, which is obtained by CO2, and side chain alkyl chain having negative charge, that corresponds to corresponding alkyl halide, and alkyl halide get negative charge only we can use the formation of Grignard reagent, otherwise we cannot get. And here, that's why when alkyl halide react with magnesium, we can get Grignard reagent, and that react with dry ice, we can get corresponding acid. Now when we change the charge, instead of positive, when we can take the negative charge, then the polarity has been changed, which is not a natural one, it is unnatural, and that's why here we can get negative charge. Now again, how this negative charge is obtained in this case? It is obtained from cyanide. COH is obtained from cyanide, so that having negative charge, and this alkyl side chain having positive charge, again it corresponds to Br. In both the cases, the starting when we can use reagent, that is magnesium, it can act as a anion, and when simply we can use another nucleophile, then act as a aliphatic or electrophile. So such kind of when we can change the polarity, the reaction should be changed. So this is another example that we have observed the Umpolong approach. So generally the negatively charged such kind of carbonyl carbon is obtained from cyanide, because cyanide get negative charge. So negatively charged carbon is obtained from the carboxylic synthon can be obtained from corresponding cyanide. So since formula and acyl anions are not accessible, so one has to use synthetic equivalent of these such kind of anions here, and Umpolong is the generally we can use in the synthesis, which is not generally carried out by normal condition, and that's why it required one or two step more, because first of all you have to prepare reaction with corresponding aldehyde or ketone with 1,2 thiol dithiol, and we can protect that one, and then we can carry out reaction with base to form carbanion. Okay, so in this way such kind of Umpolong approach is commonly carried out. So here also, similar to aldehyde and ketone, the acid are also obtained from aldehyde, obtained from alcohol, obtained from cyanide, obtained from ester. Okay, and here also it is obtained from alkene as well as ketone. So such kind of special reactions are also there. So you may apply such kind of reaction to prepare corresponding acids. So now this session is open for disconnection. Again, I have observed the total number of strength is a little bit less because of inconvenience of our regular part, but definitely from tomorrow there should be a improvement in the lecture. That's why I have used our channel which is given by college. So by using this method, you have to attend the lecture. So here, in both the cases, I have used aldehyde ketones as well as acid. If you have any kind of doubt, you should ask in this case, because after this we will move towards the mostly derivative of acid and amine, and then we can move the uh, second part of this topic that is important. That is nothing but mostly we can use 1 2 1 3 1 4 disconnection. But the basic thing is that when we can carry out such kind of disconnection, again we can apply the same thing that you have learned up till now. And that's why, even though it requires, that is nothing but we are today we have 8 lecture. So on the 8th lecture, almost we have complete the functional group part. So only amine is there, and some derivative of acid. So on next lecture we will see the derivative of acids and amine, and probably after that we can start the 1 2 1 3 1 4 1 5. So almost we required more than 15 lectures, but definitely we will go slow by slow, because everyone know that. And I have observed in the initial stage that in the homework or that home assignment I have given, uh, that you have to improve yourself when we can disconnect. Be remember, when we can disconnect the molecule, we have to write down the synthon first, then synthetic equivalent corresponds to that, and after that when we can reach to the starting material, again we have to write down the synthesis, because the half part is for your synthesis. Otherwise you will get only half part marks. In the home assignment I have observed that one out of two, one example is little bit tricky. Be remember, always two examples are not very easy. And at present I am given just a simple example to disconnect you the molecule. Very simple examples I have given, but later on when I will give the some drug molecules, or even some synthesis that you have already learned, simple like naphthalene. So you have to disconnect that molecule by using this. Today I also take that in presence of in aldehyde ketone. I will try to take that example, but uh, first of all I would like to discuss with you that when I will give that example, how that can be obtained, because you must know the naphthalene synthesis. Okay, and just you will know that at the SYBSc level you have learned that part. Okay, that is in polyhydrocarbon. You have learned that part, and that kind of example definitely I will give. Generally, in the at MSc level, that examples are definitely given. So we will going through such kind of example. First of all, in one today you must see the how naphthalene is synthesis, and then I will give that example, because in that the second last step is probably formation of ketone, that is carbonyl group, and then undergo Clemenson's reduction, and reduction we can get corresponding uh, naphthalene. Okay, so if you have any kind of doubt regarding this part, Sagar.
No, sir. Okay.
Okay, Pratik, do you understand? How many you have tried to repeat the homework, that home assignment I have given, and especially mentioned that that second example or both example you have to repeat? I have not given in our regular lecture that part, because you have to think over it. And at the last stage, if you are not able to give the proper disconnection, then and then only I will take in the regular lecture. Whatever the remark that I have given in a home assignment, you should try to disconnect by different method, so that we will do see how the disconnection is get the proper way. Okay, Sahil, you have any doubt?
Hello, sir.
Okay, Ankita.
Sir.
No, sir.
Okay,
Hello,
No.
sir.
Sonobar. Huh? Anyone having doubt? Please ask.
हा सर ते तुम्ही
Neha,
फर्स्ट एक्झाम्पल घेतलं ना सर ते परत सांगा ना.
which one?
First slide, first example
First
दिखा
slide is
तुम्ही.
just that was the last slide of previous lecture. In that we have given the
ते नाही सर,
aldehyde.
त्याच्या पुढचं तुम्ही ए बी पाथ दाखवलं ना, नायट्रो पॅरानायट्रोचं ते एक्झाम्पल होतं
Okay, okay,
ते.
okay. So in that case, we remember that in both the cases there is a Federcraft acylation, right? And when there is NO2 group and methyl group is there with respect to acyl chloride, uh, generally when there is electron donating group, what will happen at para position? Anyone can say? When there is carbonyl group at one position and electron donating group at fourth position, what will happen? It can donate the electron, right? And when it can donate the electron, delocalization on the benzene ring is takes place and we can get corresponding O minus. So the positive charge is not remain on this carbonyl carbon, which is going away from the carbonyl carbon. And that is that part you have already learned at the FYBSc, dispersal of charge for the stability of the carbocation carbanion. And those who have at FYBSc in my class, then definitely they have no, because in the stability of the carbocation and carbanion there is dispersal of charge is there, right? Always we have to observe, and uh, in that example we have to consider that part. Okay, and that's
हा
why
सर.
we have preferred uh, the functional group which cannot uh, get, because if there is dispersal of charge, the positive charge is not remain on the carbonyl carbon, which is not much more electron deficient as compared to the electron withdrawing, and that's why we can prefer that path.
हा सर. ओके.
Okay, so I think mm, in that regard you must think over that. Such kind of example you have learned at undergraduate level also, and just I have taken one example. So there are so many examples are there regarding that. At initial stage I have going through the very very simple examples that you must know that, but later part mostly at the homework part I will give you such kind of examples in mostly carried out in drugs, because after MSc you should join the any industry and they have not having a such kind of simple example. I will definitely give the some drugs, even in example when such kind of drugs or such kind of molecules are there, I have mentioned that such kind of compound is used for as a perfume or such kind of insecticide and such kind of intermediate of drugs, because that is very essential part in research R&D center, always those having the strong area of retrosynthesis, because in uh, interview always this question is asked, which is your favorable part in your organic synthesis. Those students who focus on spectroscopy and retrosynthesis, definitely they will join very fast, because that two are the very important part in the research. So you must concentrate on both these topics at second paper as well as in the third paper of your third semester. Okay, no doubt in that also I have one topic, and combined problem session is always towards me, but first of all we have to complete UV IR NMR mass, then I will go to there. And again for this we required almost again 10 lectures are required. So uh, when we can carry out this lecture, and hope so that probably in the next month the college will take initiative, or if the government give permit us to take the lecture physically, then definitely we will take the lecture in our classroom. Hope so that in the second week of September that maybe start. Otherwise again online lecture is going on, because the samstha is asking this to take the information how many parties completed. uh, if this pandemic situation is continued till then, you have to take exam by the part which we have done online. So that's why be serious about the thing. Whatever the part you should complete, there should be a exam if the government has says you have to take the exam. So each and every lecture and that PDF whatever given, you should write down your notebook, because it is not necessary to always each and every student to take the print of that part. And instead of that, when you can write down, there's only two lectures in a day, so you should write down that part in your notebook after completion of lecture. And in the evening part, always I have give the home assignment, because in the rest of the day you have to write down the these all things, and then in the evening part I will give the corresponding mm, such kind of home assignment. And probably in the new thing, that when we can adopt such kind of Google Meet, there is possibility that you have to give the submit your feedback after completion of each lecture. So be remember that whether such kind of situation is there, you should submit your feedback. So whole analysis of feedback is going to the Raj Shikshan Samstha also, not only towards college. Okay, so I think today we will conclude this, and we shall that to on next lecture we can start with the derivative of acid. Okay, thank you.